Hello, this is Maths with Lemon, and in this topic we will see the radians connected with arcs and areas. Let's see. Up until now, you have used degrees to measure angles. Just like we can measure lengths with different units, we can use also other units for the angles. So angles can be also measured in radians. The symbol for the radian is that small s above the number, the letter. So, but basically we want to see what is a radian. One radian is defined as the angle at the center of an arc where the arc length is equal as the radius. Is exactly the same values with the radius. It's almost an equilateral arc, so basically you see, because I don't have a straight line, it's an arc, it's almost an equilateral. It looks like that one radian is roughly 60 degrees. Let's work out how much is exactly in degrees. We know that arc length is a fraction of the circumference, 2πr. The arc length, the length of the arc is theta over 360, the angle, times 2πr. In this case, the length of the arc is r. So here, if I'll substitute, I will have this result, and then if of course I can cancel r's, and then I will have 1 equals theta over 360 times 2 pi. Rearrange to find the theta, so theta is 360 over 2 pi. So 1 radian is 360 degrees over 2 pi, which is roughly 57.3 degrees. You can also say that 1 radian is 360 over 2 pi. So I see that 2 pi is equal with 360 degrees. A full circle is 2 pi in radians. Or that pi is 180 degrees, pi radians. It is good practice to use the pi symbol, as it is more accurate and easier than writing it out as a long decimal, because we know that it's an irrational number, pi. We can now convert simple angles from degrees to radians. So basically pi is 180 degrees, pi over 2 will be 90, right angle, pi over 3 60, pi over 4 45, pi over 6 30, and 2 pi is a full turn or circle. You can convert any angle from degrees to radian as a function of pi. Convert 24 degrees to radians. 180 degrees is pi. 1 degree is pi over 180. So 24 will be 24 times pi over 180. So basically it's 2 pi over 15. Radians make finding arc lengths and areas much easier. Why? Here is a theta given in radians, and r is the radius of the sector. How much is the arc length of L? Arc length L is theta over 2 pi times 2 pi r, where theta over 2 pi is the fraction of the full term. So remember that 2 pi is 360 degrees. 2 pi r is the circumference. I cancel 2 pi's from the denominator and numerator, and I have that L is r times theta. So basically you can find the length of the arc just multiplying the radius times the theta in radians. Arc length L equals r theta, theta given in radians. The area is also more simple. The area of a sector is theta over 2 pi times pi r square. Pi r square is the area of the whole circle. I cancel the pi's, so the area of a sector will be 1 over 2 times r square times theta, where theta is given in radians. Let's see that. Find the arc length L and the area of the sector. Radius is 3.1. Here I have 0.60 degrees in radians, so the arc length will be 1.86 centimeters. Find the area of the shaded segment. Find the shaded segment. To find it, we need first to find the area of the whole sector. Then we can take away the area of the triangle and find how much is the segment. The area of the sector will be 1 over 2 times r square theta. The area of a triangle is 1 over 2 times a, which is r, times b, which is r, times sine of the theta of the included angle. This comes from, from the formula. We have seen that. So the area of the segment will be 1 over 2 r square theta minus 1 over 2 r square sine theta. Now, find the area of the major segment, shaded here. Find the area of the major sector. 1 over 2 r square 2 pi minus theta, which is the angle. And the area of the at the area of the triangle, which is 1 over 2 r square sine theta, and the area of the major segment is this one. These formulas will work only if you put your calculator into radians mode. There will be another video how to transform with your calculator easily degrees to radians and radians to degrees.